Uh, Hello. I will explain my codes for linked lists. Uh, so what I did here for the methods contains remove, get, index of, and the last index of set, etc. Um, for the first one, uh, contains uh, I set the current for the root, and then if current is not equal none, uh, if the current element which we pass into the function, if it's in current equals, then we return true, then continue. uh, if not, for the next element, and if we did not return true in this, then we return false because we did not find the elements. And for remove, uh, what I did here was if the head element is equals the element, then we remove first and return true. This is O1 time complexity. Else we loop through the lists, and if the next element is equal the element, then uh, we set the current as a we are deleting the current element, so we have to store the previous element for that to link to the current next element. So we point the previous next to the current next. That's how we delete it, and then garbage collection will do the rest, and then we return true if it was successful. Else we return false. Forget uh, to what I did here was I wanted to make it so that it is similar to Python list. So I implemented -1. So if you pass in -1 as a parameter, uh, then what Python do in its list implementation, it uses size of the list, and then it takes away if you put in -1, then it takes away -1 from the size. So uh, then it returned the index. Uh, and of course, if size equals 0, then we return none. And if index is below 0, uh, that means if it is below 0, then we get first, because this is not below 0. This is uh, within the self.size. It is a positive number if you take away the index here, and if it's a negative number at the end, then we just get the first element. In Python implementation of lists, it returns uh, index error, but here I just decided to return the first element. And also for if the index is more than the size of the list, then we get the last element. And else we loop through the list. Two, we find the index, and then we return the index. We return the element, the current element for that index. And for index of, if for index of what I did here was if the first element equals the element, then return the first index, which is 0, and else we loop through the list until the node element matches the element, and then we return the index. If we did not return anything here, then we return negative 1. And for last index of uh, uh, this is ON, because we have to loop through the whole list to find the last element that matches the element, because this is the last index, which is which means that if we find an element, then we do not return it. We continue looking until we find another element that matches, and then we return the last element, the last index that matches the element. And to do this, we have to loop through the whole list, because we don't know if the next element is the last one. So uh, then we return the index of the last element, which is negative 1. Uh, for set, this is we are replacing an element at the index with another element, and uh, first we check if the list contains the element, and if it does, then we set the current. We set it to the head, and then we loop through the list, and if we loop through the list until we find the element at the index, and then we set the element, and then return none. To explain the, the how it what it does, the code. First, we add elements, and then I comment out some code there. For the set, we uh, It was the index and then the element. So uh, if we run this uh, and run it again, uh, we wait, let me okay for set the implementation for set it was index and element. So we are for index 5, which is 0, 1, 2, 3, 4, 5 at the last elements. We are replacing that for 9, but it does not work. So I discovered implementation faults because I misinterpreted uh, what the set does. I thought you had to have the element, but you did not. You just need the index and then just replace the element with the element. So what I did here instead for set, I just set current to self dot get node, and if we get a node from there, then we set the current element to the element. Get nodes uh, is just the same as get, but instead of returning an element, we return a node. So instead of get first, get last, which return elements, we return just a node, return head, return tail, and else we loop through the list until we find the current node and return it. If it did not return anything, we return none. So yeah, and as you can see, we set the index 5, which is 4 here, and replace it with 9, and we get 9 as a result. Uh, to explain the list's index of so what I did here was uh, uh, if we run this, uh, let me do it again. If we run this, then for index 7, uh, it is not in the list. So for index of uh, we are looking for the 7 element, which is in index 2. So if we run it, then we get 2 for the seven element. For 4, we get the last element, which is 5. And for 0, which is not in the list, we return a -1. And for last index of, uh, if we run this for index 3, there are 2 trees here, but we are returning this tree, which is at index 4, and then 9, which is not in the list. We return -1. And for 4, which is the last element, we return 5. And for get, um, so we get 3. Get was you return the elements at index. Get for index 3, you return 0, 1, 2, 3, 1. You get 1. For 4, 3. For 5, 4. For 6, which is above the size, we return 4. And for negative 1, which is self size minus this, negative 3, which is uh, self dot size minus 3, uh, which is 5, 4, 3, 0, 1, 2, 3, 1 here. And for negative 2, which is 3, here 3, and for minus 5, which is uh, size here is there are 6 elements. Negative 5, which is 1 index 1, 6 here, and for minus 6, 6 minus 6, 0, which is 3, and for minus 7, we get a negative index here, and then we just get the first element. And contains. Uh, this is contains was uh, return true if this list contains the elements. So this here looks for 9 in the in the list, but it did not find it, and returns false here. So yeah, if I do uh, lists that contains 7 here, what do I get if I print it? I get true. If I print this, I get false because it's not in the list. Uh, if I remove, it is remove elements 4. Uh, so if I run this and then print the lists, and we remove 4 here, and if we remove something that does not exist in the list, then we do nothing. And if we remove 3, then we remove the first occurrence, which is the first, uh, then that's removed. If we remove 7, remove 7 here. Uh, 7 here is gone. If I remove 3 and 3 again, then both of the trees are gone. And for clear at last, if I do this, uh, then the whole list is cleared. So yeah, thank you for watching.